Alright class, today we're going to work through Chemistry Handout 5.3 and the worksheet 5.4 titled Types of Reactions. So again, have out Chemistry Handout 5.3 and worksheet 5.4. So our goal for this short lesson before we get some work time is to name the 5 types of major reactions, or 5 major types of reactions, and to possibly predict some products. That's our end goal. Is I want to be able to give you some reactants and you tell me what you can make with those reactants. So on worksheet 5.4, this is another balancing sheet where we're just going back and forth and balancing these reactions. Okay, but each of these reactions is organized into a type of reaction. So as you can see right here, it says combination or synthesis reaction. So all of these in this first section, number 1 through 13, are combination or synthesis reactions. Okay? So what is a combination or synthesis reaction is what I'm going to go over first. But just to make sure you know how to balance, again, I go back and forth. I have 1 calcium, 1 calcium. 2 hydrogens, 2 hydrogens. 2 oxygens, 2 oxygens. So number 1 is actually balanced. Okay? Now in this synthesis reaction, once we learn what that is, what I want you to do in these boxes where it says description is to describe what is a combination or synthesis reaction in your own words. Okay? So we're going to go over the 5 major types of reactions today. You're going to jot down a few notes about each one. And as you're balancing these, you're going to write one description summarizing each type of chemical reaction. Okay? So what we're doing is looking at now handout 5.3. It says organizer for types of reactions. Okay, and this is going to be a summary of the 5 major types of reactions that we're going to look at today, which are synthesis, decomposition, single replacement, double replacement, and combustion. Okay. All right. So when we're looking at a chemical reaction, what you should be asking is, well, what's going on? And to be able to figure out what's going on, you need to observe. So when you're observing, just a couple things I want to remind you of, is you must never assume you know anything about the chemicals, and accuracy and attention to detail is a must. Because, in all honesty, when scientists are doing these experiments in cartoons and in television, they commonly portray these scientists as making these great discoveries and yelling Eureka. But in reality, I heard this on a podcast recently, a scientist's famous words for making a great discovery are, that's weird, or that's strange. Because in reality, these discoveries are commonly made by mistakes. And that's where attention to detail comes into play. And attention and paying attention to actually what's going on in these reactions. Okay, so just keep that in mind whenever you're making observations. We're obviously not going to look at a ton of reactions today, demonstrations today, but pay attention to detail when you're making these observations. All right, so when we're looking for a chemical reaction, we learned this in a previous class, we're looking for 4 main pieces of evidence. Now we don't need all 4 to know that a chemical reaction has taken place, but you need at least 1. And those 4 pieces of evidence are formation of a gas or evolution of a gas. Example, if it starts bubbling, not by heating it, but by mixing substances together. If they start bubbling, that's evidence of a gas being produced, and that is evidence of a chemical reaction. You could also have change in heat or light being emitted. Okay? This is a change in energy, which is also evidence of a chemical reaction. Example, glow stick. To get a glow stick to react, you got to crack it, and that allows the reactants to combine with each other and emit light. Formation of an insoluble precipitate, a fancy way of saying a solid is formed, where liquids mix together and produce a solid. That solid is a new substance, therefore evidence of a chemical reaction. And then a change in overall intensive properties. This could include colors or basic properties of the substance. Okay? So those 4 pieces of evidence are going to allow me to know whether or not a chemical reaction has taken place. Okay? And if you guys need a little time to write this down, you can pause the video and take a few moments and jot down these notes before we get into synthesis reaction. So our first major type of reaction we're going to talk about today is a synthesis reaction, this right here, okay? Where I have 2 substances, you could even have 3, but typically 2 substances react to produce one product. So how do we identify a synthesis reaction? Well, it's when 2 become 1. Typically, you're going to have a metal and a nonmetal combine to form one compound. So the general form of this reaction is R plus S produces RS, with R representing typically a metal and S representing a nonmetal. And everything in red here is what's going on in your note guide. So please take some time and jot these down. Okay? So the example we're going to look at, and I'm sorry, but we're not going to get to this today just because I'm not here. The example we're going to look at next class is we're going to mix zinc and iodine together and see what it produces. But I want you to take a minute before we do move to the next slide and try to predict what that can make. Okay? And to think about that, to give you a little clue, okay, if you have bologna and bread, can I make a turkey sandwich? Hopefully your answer is no. You can make a bologna sandwich, but you can't make a turkey sandwich. So use what you start with to predict what you can produce. I start with zinc and iodine. What can I produce? Okay. All right, so hopefully everybody's got a minute to jot down these notes. What we're going to do is write down one more thing, one more example, the Hindenburg explosion. And again, next class on Thursday, we'll take some time and go over these examples in a little more detail, but please fill out your note guide so that we have this information ready to go so we can breeze through the examples next class. So what happened with the Hindenburg, and I know most of you have learned about this in your social studies class, is you had a blimp or a zeppelin filled with hydrogen, which is very reactive with oxygen. And once it reacted with oxygen, it released a ton of energy and actually burned up and produced water vapor. So we'll watch a video on this and talk about this in a little more detail next class, but for now, just go ahead and jot down the reaction that caused this blazing fire with the Hindenburg. Alright, so that is page 1. If we could all flip to page 2 of the 5.3 chemistry handout, we are going to talk about a decomposition reaction. Alright, so hopefully what you think of when you hear the word decompose, you think of breakdown. Okay? How to identify this reaction? There will be one reactant and it will break down and produce more products. This typically involves the addition of heat, light, or some energy source. And again, my general form of the reaction is opposite of that of a synthesis, where instead of 2 becoming 1, it's 1 becoming 2. Where you could have a metal and a nonmetal breakdown, but you could also have any compound, 2 nonmetals or even metals, break down and decompose. Now what we're going to look at in class is a covalent substance, sugar, breakdown. And if you'd like to, you can take a moment and predict what this could possibly make. Or you could wait for class on Thursday and we can actually look at this reaction. So again, let's take a moment, write our definition of decomposition reaction, the general form of the equation, and we can kind of ignore this prediction final analysis and save it for next class. So under please consider the following, what I wanted you to notice and what I said before is decomposition and synthesis are opposite. So if you reverse the arrow of a decomposition reaction, it becomes a synthesis reaction. So what we should understand is that they're very much related, just opposites. Coming together is synthesizing, making something. Decomposing is breaking down. So this goes under your please consider the following section on page 2 of your All right, so that's 2 out of the 5 types of reactions. Our third type of reaction we're going to talk about today is a single replacement reaction. In a single replacement reaction, I'm going to use an analogy of couples. Okay, so here we have Frank and Mary. Let's say Frank and Mary are dating and they're happy, but then comes Joe. And Joe steals Mary. And now Frank's alone. We've all seen this happen, whether it maybe happened to us, someone we know, or we saw it on television. Okay? A couple breaks apart when one significant other leaves them for someone else. Okay? Now this happens sometimes, but sometimes it doesn't happen. And the same thing happens with elements. Okay? So a single replacement reaction happens when atoms of a single element replace the atoms of a second element. One knocks out the other. So you will see a single element in a compound as the only reactants, and also as the only products. So our general form of this equation is going to be, we're going to have some element A and some compound BC. Well, C is more attracted to A than it is to B. Just like Mary was more attracted to Joe than she was to Frank. So what she did was she left Frank for Joe. So C leaves B for A. So I have A plus BC produces B plus AC. Notice how C switched partners. Okay. Give you a moment to jot this down on page 2 of your note guide. All right, some basic examples where this is going to happen is these 3. Here I have copper sulfate and iron. Iron replaces copper in this reaction. Okay. And that's a metal replacing a metal. Okay. Example 2, I have a metal replacing hydrogen. Now remember, hydrogen is a nonmetal, but it behaves like a metal. So what I wanted you to see with these 3 reactions is metals are going to replace metals, nonmetals are going to replace nonmetals. But hydrogen behaves like a metal, so hydrogen can kind of act as a metal, even though it isn't really a metal. And in this last example, I have nitrogen replacing carbon, a nonmetal replacing a nonmetal. So these are the 3 main examples we're going to see for a single replacement reaction. Okay. Now, the single replacement reaction we're going to look at here is aluminum and copper chloride. Again, we'll look at this in class. But what I want you to think about is, would aluminum replace copper or chlorine? And you can even try to make a prediction if you'd like before we look at that in class, next class. All right. If you could turn to page 3. How do we know whether or not one element replaces another? How do I know if Joe is going to steal Mary from Frank? How do I know if potassium is going to replace calcium in the reaction? Well, for that, I look at the activity series. And this activity series, we're going to learn more detail about it next class, but it allows us to predict whether or not one element is going to replace another. Whether or not lithium is going to replace potassium, or calcium is going to replace magnesium. And it puts these elements in order of reactivity. So the elements that are higher are going to replace the elements that are lower than it. So when we look and see whether or not a reaction takes place in a single replacement reaction, you're first going to look at this activity series. So what you'd look at here is copper higher than the element it's going to replace? Is copper higher than hydrogen? So I look here. Copper is lower than hydrogen. No. Copper is lower than hydrogen. Therefore, this reaction will not take place. Because copper is not strong enough to steal hydrogen's partner. And that's how we predict single replacement reactions. The halogen group is also its own activity series for single replacement reactions. If I look on my periodic table, it goes in order. And that's single replacement reaction.